Angelo Di Pietro, born 1950 in Avellino, Italy, is an engine designer who developed the Di Pietro Motor air engine. He qualified as Congegnatore Meccanico in Avellino and moved to Stuttgart to work on the Wankel Rotary engine at the Mercedes Benz research laboratories 1969 and 1970. In 1971 he migrated to Australia where he established a construction engineering company. From his early experience with Wankel rotary engines, Angelo became interested in developing a more efficient engine than the traditional reciprocating internal combustion engine, and he has worked on various alternative concepts intermittently over the last 30 years. In 1999 he made a major design breakthrough with a rotary motor which runs on compressed air. The engine was called the Angelo Di Pietro's rotary positive displacement air engine, and Di Pietro claims that his engine is 100% more efficient than competitors' products and that the reduction in friction will allow the engine to turn with a pressure of 1 psi. 1. Di Pietro targeted locations in which automotive vehicles are required but cause immense health hazards, such as produce markets and warehouses. Di Pietro was determined to find an alternative that was both environmentally conscious, comparable in desired power, and inexpensive. Angelo Di Pietro's rotary positive displacement air engine, the Di Pietro Motor, developed by the Australian company Engine Air, is a rotary engine powered by compressed air. It is smaller than any internal combustion engine, although the size may differ between models. Unlike other rotary engines, the Di Pietro motor uses a simple cylindrical rotary piston shaft driver, which rolls with next to no friction. Inside the cylindrical stator, only 1 psi, approximately equals 68 kilopascals, of pressure is needed to overcome the friction. The space between stator and rotor is divided in 6 expansion chambers by pivoting dividers. These dividers follow the motion of the shaft driver as it rolls around the stator wall. The cylindrical shaft driver, forced by the air pressure on its outer wall, moves eccentrically, thereby driving the motor shaft by means of 2 rolling elements mounted on bearings on the shaft. The rolling motion of the shaft driver inside the stator is cushioned by a thin air film. Timing and duration of the air inlet and exhaust is governed by a slotted timer which is mounted on the output shaft and rotates with the same speed as the motor. Variation of performance parameters of the motor is achieved by varying the time during which the air is allowed to enter the chamber. A longer air inlet period allows more air to flow into the chamber and therefore results in more torque. A shorter inlet period will limit the air supply and allows the air in the chamber to perform expansion work at a much higher efficiency. In this way, compressed air energy consumption can be exchanged for higher torque and power output depending on the requirements of the application. This is identical to function of the cut-off control in a steam engine. Motor speed and torque are controlled by throttling the amount of pressure of air into the motor. The Di Pietro motor gives instant torque at 0 rpm and can be precisely controlled to give soft start and acceleration control. The Di Pietro motor can be used in boats, cars, burden carriers and other vehicles. Environmental implications. Operation of compressed air vehicles will usually be pollution-free during operation. However, the energy required for compression must be sourced, and will usually be derived from electricity, or an internal combustion engine. Depending on the method used to generate the electricity, the energy may still contribute some quantities of greenhouse gases and other pollutants, especially if fossil fuels are used. However, the use of multiple alternative energy sources, such as solar panels to power generators, compressors could decrease the need for electricity created by fossil fuels. With the constant advancements in alternative ambulatory power by engineers such as Angelo Di Pietro of Engineer in Australia and Guy Negri of MDI in France, crude petroleum can be refashioned to be mainly used for industrial products such as plastics. To date, no vehicles powered by this or by other models of compressed air engines have ever reached the working prototype status, excepting compressed air-powered fireless locomotives. At YouTube.com, a video dated April 2010 with Guy Negri speaking about AirPod can be viewed. On Shark Tank in May 2015, an investor submitted a bid of $5 million to assist in marketing AirPod, which would sell for $10,000. Back in 2010, India expressed an interest to have AirPods sold in its country. In 2015, Hawaii has expressed the same interest to have AirPods sold on its island. The AirPod vehicles use a traditionally designed reciprocating piston engine. They do not use Angelo Di Pietro's rotary engine design. See also: compressed air engine, engine air research and development.